I'm going to discuss how to use residues to integrate functions that have higher ordered poles. In this one, see the denominator really has a z plus 1 cubed, as this one has a z minus 1 cubed, and so we'll figure out how to solve this. The first thing to do is figure out where the singularities occur, and the only singularity here is at z equals -1. So this integral is going to be equal to 2 pi I times the sum of the residues, but really the only one that you have is at z equals -1. Well, we can use a formula that you can basically look in your resource. Residue at z equals -1 is equal to 1 over the order of the pole, right? This is really z minus 1 over z plus 1 cubed. So the order of the pole here is 3. So it's 1 over 3 minus 1 factorial, generalizes to 1 over n minus 1 factorial, times the limit as z goes to the singularity, -1 in this case, of the 3 minus 1th derivative, again, generalizes to n minus 1, times this thing to the 3 times f of z, which is negative over z plus 1 cubed. So notice that all of these things here, they come from a formula where you just plug in n into those. And this is just takes the place of f of x. So now we just compute, right? 1 over 3 minus 1 factorial is the same as 1/2 times the limit of the second derivative of z minus 1 cubed. Okay, well, now I just need to take the limit, take the first derivative, and I'm going to get 3 times z minus 1 squared. Oh, now I need to take a second derivative, limit as z approaches the singularity, -1, and I get 6 times z minus 1, which equals 1/2 times 6 times -1, this should be -1 minus 1, that equals -6. So the answer to this is -2 pi I times -6, which equals -12 pi I. Alright, so we can take a look at this one. This one has two singularities, but the first one's going to be easy to take care of. So this is going to equal 2 pi I times the sum of two residues at z equals 0, there's a residue from the z, and at z equals 1, there's a residue. Alright, so for z equals 0, it's pretty simple. I can just use the fact that the denominator has a simple 0. So this is equal to, I can rewrite the whole thing as z minus 1 cubed all over z, that's the integrand. And since this just has 1 power to it, the exponent here is 1, all I need to do is take the derivative, evaluate the top at z equals 0, and evaluate the bottom at z equals 0. So this just equals e to the 0 over -1 cubed all over 1 evaluated at 0. So this just gives me -1. Alright, so for z equals 1, I can just use the same formula I did over here. What I really want is 1 over, again, the order is 3, 3 minus 1 factorial, times the limit, as z goes to 1 in this case, of z minus 1 cubed times f of x. Except I forgot the derivative. So there should be a derivative 3 minus 1 over dz 3 minus 1. So I need a second derivative. So this is equal to 1/2 times the limit of the second derivative of e to the z over z, which equals 1/2 times the limit. The first derivative, using the quotient rule, I get z e to the z minus e to the z over z squared, which equals 1/2 times the limit of, if I take the derivative of this, I get z squared times z e to the z plus e to the z minus e to the z minus 2z times z e to the z minus e to the z all over z to the 4th. So you just plug in 1 and you're going to get